There you go. With coconuts. Oh, it got kind of off topic a little bit. All right, so I hope everybody is having a good day. If you'll recall, yesterday I said we weren't going to move on with the next lesson. We were just going to go ahead and take the class period to work on your assignment. The assignment I gave yesterday, which is due on Monday. There are extra copies right over here in the filing cabinet by Jason. All right over behind Adolfo. You'll note, remember, numbers 1 through 4, I wasn't going to have you work. We're just going to omit those. And on each of these problems, anything extra it was providing, I'm not interested in that. We're just looking to sketch these graphs. Okay, that was the whole point of the lesson. So there are a few that I'd like to go ahead and, work together, and then maybe we can get some folks up here to go ahead and do a few more. Or if at that point you just want to turn it over and just take the rest of the period, that is up to you. But let's see. I think it was on the last page. Yes, like number 13, number 14, and number 16. They all do this particular idea. So 16, then we have 13 and 14. Why don't you go ahead and choose one of those, and we'll start with that. Which one would you like? Yes. What's that, man? 14. Okay. We want to graph 14. Y equals -2 cosecant of x minus pi plus 1. All right. So here's the thing. We introduced secant and cosecant yesterday, and the strategy we talked about was we're going to graph these by graphing their reciprocals. In fact, what's the reciprocal of cosecant? Okay, it's sine. So I just remember we're not interested in these. So I just want to graph -2 sine of x minus pi plus 1, and then we're going to use him to get the graph that I actually want. So we're going to draw that graph, very lightly. Okay, so we want sine. Let's go ahead and start with my x's, which means a compound inequality. So for both sine and cosine, we set that between 0 and what? There we go. Okay. For sine and cosine, it's always between 0 and 2 pi for your compound inequality. Now, we will visit a tangent and a cotangent, and I'll go ahead and write those down for you in just a few moments. But can anybody tell me what's going to go in the middle? Whatever's in parentheses, the horizontal changes. So x minus pi. And now I want to solve this for x in the middle. So how would I get rid of a negative pi? Okay, so I'm going to do just like you said. I'm going to add pi to the middle, to the right, and then to the left side. Those are going to cancel. So we have pi less than or equal to x, which is less than or equal to 3 pi. Okay, so we have my compound inequality solved. Okay, we are good to go. So I'm going to put him to the side for just a second. Let's turn our attention to the critical values now. What were the 5 critical values for sine? We started at 0, maximum, 0, minimum, and then back to a 0. Now, is there anything happening here that's going to change those 5 values? What? There we go. The -2 and the +1 are both outside the parentheses, so they will specifically take care of these y values for me. So every one of them, I want to go ahead and multiply by -2 and then add 1. So I'm going to take 0 times -2 plus 1. That's just going to be 1. Then I'm going to take the next number, 1. Multiply by -2, add 1. That would give me -1, yes. So does everybody see where I'm getting these values from? Okay. So 0 would give me the exact same result, times -2 plus 1. Now we have -1 times -2 plus 1. That would give me 3. There we go. So is everybody okay with how I transformed my critical values? Okay, no problems there? All right. Well, let me take off these originals because we want these transformed ones. Now I'm going to take the compound inequality that we created, and I'm going to pair it up with these 5 values. The lower boundary always gets paired with the first one. The upper boundary always gets paired with the last one. Okay. Now, is the distance this time around 3 pi? No, because the lower boundary didn't remain 0. So what is 3 pi minus pi? So the distance I'm looking at is 2 pi, and we always, always, always divide by what? 4. So 2 pi over 4, that would become pi over 2. All right, so that's the value that I'm going to be adding over and over again. Okay, so what is pi plus pi over 2? 3 pi over 2, very good, plus pi over 2. 2 pi plus pi over 2. That would be 5 pi over 2, yes. Okay, absolutely. Now, you're dividing by 2, right? So you could look at the pattern. Pi would have been 2 pi over 2, right? Then we add another, that would be the 3 pi over 2 plus pi over 2 would be 4 pi over 2. Then we would have 5 pi over 2, 6 pi over 2. And if it helps you to go ahead and write out using a pattern first and then simplify, please feel free. Or just go ahead and add as you go along. All right, either way, we did get to 3 pi. Now remember, those are my x's. The critical values are my y's. And I've got ordered pairs that I can just plot my graph now. Now remember, this one we're going to go ahead and draw very lightly because it's not the sine graph we want the cosecant graph. Okay, so pi 1. All right, so the first thing I'm going to start at 0. I'm going to go pi right and then 1 up. Then I'm going to go 3 pi over 2, negative 1. Okay. 2 pi is going to give me 1. There we go. 5 pi over 2 would give me 3. Now, where is that going to be?
It's going to be like right where the box is.
There you go. So right here. Okay, so 5 pi over 2 would be 1, 2, 3. So this is 5 pi over 2. Okay. And then 3 pi 1, we're going to be off the grid for that one. Okay. So now let's just go ahead and start repeating these back in the other direction. Okay. So besides this 1 here, what would come next?
It would be like 1/4 pi, right?
No, because think, how far are these guys from each other? Okay.
Oh, okay.
Now the next one would be a
So it would be pi over 2, negative 1.
pi over 2, negative 1. Then it would go here. Then it would go here. Is everybody okay? All right. And then we can continue that here. Continue that here. There we go. And wait a minute, did I make a mistake?
Because if you look at 2 pi, it's at a 1, then it goes up to the 3. So you're stuck at that. Wait. It's pi.
Yeah. I think I made a mistake, though. I think I did. Because the next one would be 3 pi, which would be a 1, right?
Yeah.
Okay.
You went up to the...
So I
Down to this, yeah, you went down to the negative 1 too soon. It should have gone up.
Because, I swear it's like, so it's...
hold on. I'm getting thrown around on this.
Yeah, it should go on the pi over 2. It should be a 3.
It should be a 3?
No.
No.
No, because it would be a minimum, because if you take that and you just do it all the way around, it's going to end up like...
Okay, see, the highest that we're going to go here is 3. The lowest that we're going to go is 1. So right here we've got my midline at plus 1. Okay. I don't know why I'm getting all thrown around on this one. Okay. So let's see, the next one would be at 3 pi 1. So if I were to start working backwards, it would be, yes, you're right. Yes. Antonio's right. Okay. It is absolutely right. And then we start working backwards. Then we would have a 0, a minimum, then back to a 0. Then we'd have another maximum. That's right. Yes. That is absolutely right. I kind of got thrown off on my pattern there. Apologize about that. Okay. So now this is the sine graph, because see, the next one here would be on 0, the midline again, so I'd have to repeat that. Yep, you're right. Okay. Good. Now, here's the thing. This is why I chose one of these three problems in particular. What does both secant, cosecant, even the other two have that sine and cosine don't? They got those asymptotes, right? Now, we've always marked the location of the asymptote where it crosses the x-axis. But wherever the midline goes, that becomes your new zero. That's basically the new x-axis. So see, that's why I went ahead and drew the midline here where y equals 1, because wherever the graph touches the midline, that's where you're going to have your asymptote. Okay, not where it's touching the x-axis anymore. If it has a vertical shift, where does the graph touch the midline? So I'm going to have an asymptote right here, 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 and here, because that's where it touches the midline. Okay, that's the only thing that I wanted to go ahead and show you because we didn't get to that yesterday. So if there is no vertical shift, you do look at the x-axis. Okay. Now, how do I finish off the graph here? I'm missing something. Yeah, there you go. Remember, they look like what? They look like parabolas, but we're going to call them branches. Everywhere this graph has a maximum, I'm going to have a branch opening upward. Everywhere there's a minimum, I'm going to have one opening downward. And then now I'm going to go back and erase the sine graph. So there we go. If you leave it there, that's fine. I mean, that's not a problem. That's not a problem at all. I don't have them on my key, so just... Yeah. And there you go. That's it. That's it. So I apologize. We kind of got off to a rocky start because I messed up on my points. Okay. Won't happen again. Or at least I'll try not to. All right. Good. Good, good, good. Okay. Do you want to go ahead and do another one of those that I circled? Okay. All right. You want to do 13? Okay, let's do this one. Now, we can go ahead and start off by drawing the midline if we want. It would have to be y equals what? -1. Remember, the midline is always dependent on that value of d, the vertical shift. So at -1, that right there should be halfway vertically through the graph. Okay. So let's see if we can get there. All right. Now, what would the reciprocal of 2 secant of 2x minus 1 be? Okay, cosine. So I'm just going to replace secant with cosine. So we want to graph 2 cosine of 2x minus 1. Okay, and then this will give me this secant graph we're ultimately wanting to get. All right, so what would you like to start with? The compound inequality or the critical values? Compound inequality, okay. So for cosine, we always put the compound inequality between 0 and 2 pi. In fact, what's going to go in there? 2x. Whatever's in parentheses is going to go right there in the middle. Okay. Now, I want to get x in the middle by himself, so how would I do that? Divide by 2. Divide all three parts. So 0 divided by 2 is 0. Less than or equal to 2x over 2 is just x. Less than or equal to pi. 2 pi over 2. Okay, so we've simplified my compound inequality. Okay, now we're going to go ahead and move over to my critical values. All right, now we saw the critical values for sine a moment ago. What are the critical values for cosine? So we started at maximum, 0, minimum, 0, and maximum. Okay. Now, is there anything happening here that will change these 5? Okay, so we are first going to multiply by 2, and then we're going to subtract 1. All right, so 2 times 1 minus 1. That's just 1. Does anybody want me to write them out like I did on the previous problem? Yes? Okay. So I'm taking the 1, I'm going to multiply it by 2, and then we're going to subtract 1. So 2 minus 1 does give me 1. Now the next one is 0. So 0 times 2 minus 1. That would be -1. And I know this other 0 would give me -1 as well. And I know this last one should give me 1 as well. Okay, the only one left is the -1 in the middle. So -1 again times 2 minus the 1, that would be -3. So these are the y values that I need to use in my graph. Okay. Now let me remove the originals. Okay, we got the new ones. Now I'm going to go ahead and connect my compound inequality to the 5 y's I just created. What is 0 going to connect with? Okay, that first one, so 0 right there. The pi will go with the last one. Okay. Now, how far a distance is it from 0 to pi? Okay, well, it's pi, and we always divide by 4. So this one doesn't simplify. I just want to add 1/4 pi over and over again. Well, the first one's easy. 0 plus pi over 4. Pi over 4 plus pi over 4. Okay, so that's pi over 2 plus pi over 4. Okay, 3/4 pi. And will 3/4 pi plus pi over 4 give me pi? Yes. Okay. So is anybody confused about how we got those 5 ordered pairs? Everybody gets the point. Because their coordinates are points. You'll laugh later. Okay. All right, let's take a look at the first one. So I want to graph 0, 1. All right, so 0, 1 would put me right here. Then we have pi over 4, so that's halfway between 0 and pi over 2, but I want to go down -1. So see, that one is on my midline. Then we have pi over 2, -3. All right, so we set a maximum, a 0, a minimum. Then 3 pi over 4 would give me -1. So we're back to a 0. And then pi would give me 1. There we go. So now let's continue the pattern. What would the next one be? Okay, so it'd be a -1, so a 0. Then -3. Then a 0. Then a maximum. And I can even do this in the other direction as well. I could go 0 minimum, 0 maximum. And I might as well just go ahead and fill in the whole thing. Why not? Okay. All right. Okay, so is everybody okay with that? Let me go ahead and sketch my graph. Now, typically, we always look to the x-axis where you're going to have your vertical asymptotes. But if there's a vertical shift, like these numbers that I've highlighted here, we want to look to where this graph crosses the midline. Okay, so I would have a asymptote right there. Okay, so there's going to be quite a few here. So I'm going to have one here, 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 there. Okay. And it makes sense because the transformations you learned in Algebra 2, if you're multiplying x by 2, remember you have to take the reciprocal. What's the reciprocal of 2? 1/2. So it makes sense this guy is half as wide as he should be. Okay. Now there's something I'm forgetting here. How do I finish off the graph? My branches. Everywhere there's a maximum, I draw a branch opening up. So there's 1, 2, 3, 4. So I was able to fit 5 of those on that graph. And everywhere there's a minimum, I'm going to have a branch opening down. There we go. And then I can go back and erase the cosine graph.
Do you want us to add like one that's coming off kind of the graph?
What's that?
Like, so you know, if you would have kept going and like to the end of the box, like you could have got.
Oh, you mean like right here?
Yeah.
If you want to. I mean, if you're showing me at least, a couple of periods, you're good to go. Here, we're actually showing several periods.
So is that okay if we do it like that? So like, say we get another one that's like that one. I want to show you like maybe like.
Oh, you just kind of went off the graph?
Well, no, I was just saying like if we get another one like that, like.
Uh-huh. Sorry. Okay. Oh, yeah, not filling the entire grid? Yeah, as long as you're showing me a couple of periods, yeah, you're fine. You're fine. Yeah, that's fine. Okay, what do we think? Okay. Do you want to go ahead and try a tangent or a cotangent? Okay, which one? But which problem, though? 15? Okay, let's take a look at 15, cotangent. Now, let me go ahead and write this out. Again, we're not interested in anything else the problem is saying. So left, right asymptote, man, don't care about that. Now, if you're going to graph cotangent, we're not going to do so by graphing the reciprocal. We are going to go ahead and just graph him from what we know. His compound inequality, though, cotangent always has to go between what? 0 and pi. Yes, you have to use consecutive asymptotes. Okay. So every cotangent problem, you'll start between 0 and pi for the compound inequality. Let me go ahead and find a tangent one. Let's see here. There's a tangent on number 9. Okay. So when you want to graph this one, every tangent problem, what's the consecutive pair of asymptotes we use here? Okay. We start negative pi over 2 and pi over 2. Okay. Here's another cotangent. So we're going to start that compound inequality between 0 and pi. Okay, so remember, sine, cosecant, and secant will all start those between 0 and 2 pi. If we're trying to graph cotangent, we're going to go 0 and pi on the compound inequality. If we're going to graph tangent, then it's going to be negative pi over 2 to pi over 2. All right. And which one were we graphing? Number, was it 15? Okay, we're doing 15. All right, so what am I going to put between 0 and pi? Okay, 2x. Again, whatever's in parentheses. Okay, now just like the previous problem, I want to go ahead and get x in the middle. So I'm going to divide by 2. Divide by 2. So 0 divided by 2 is still 0, less than or equal to x, less than or equal to pi over 2. All right. Now what? Okay. Okay, so what are the criticals for cotangent? Remember, one period we have to start with a asymptote. So we have our undefined symbol. Okay, so this one was a positive one? There we go. Would everybody agree? Okay. Remember, for tangent, the critical values went undefined, -1, 0, 1, undefined. Absolutely right. Good. Okay, now, is there anything here that's going to be changing those? Yeah. So we're not adding or subtracting anything. The midline is still going to be the x-axis, y equals 0. But the only thing outside the parentheses here is -2. Now, what are the two values that are not going to be changing? The asymptotes. So they're going to be staying exactly where they are. Okay. Now, for this one right here, I just want to multiply it by -2, which gives me -2. Then I want 0 times -2. And then -1 times -2. There you go. So these are my y values that I'm going to use. Is everybody okay with how I did that? Okay. Let me remove these. There we go. All right. So I have the y values that I need to use. I have the compound inequality. We just have to kind of sync them up. Where am I going to put what? Okay. Well, let's see. What's going to go with this first undefined here? 0. It's always the lower boundary. What's going to go with the other one? Pi over 2. Okay. Now we got to figure out what the values in between are going to be. There you go. So the distance between 0 and pi over 2 is pi over 2. But we always, always, always divide by 4. Now you can't. 4 can be a fraction if you put it over 1. So if we divide by a fraction, that means we can multiply by its reciprocal. So pi over 8. So I want to add pi over 8 over and over again. Okay. Now remember, if you have to, use a pattern and then go back and simplify. So what's 0 plus pi over 8? Well, that's pi over 8. Plus pi over 8. So 2 pi over 8 plus pi over 8. 3 pi over 8. And then this last one would be 4 pi over 8, right? But will 4 pi over 8 give me pi over 2? Yes. Is there any other one that I need to simplify? 2 pi over 8. So I can go back and say that's really pi over 4. There we go. Now, what do the undefines tell me again? That's where my asymptote are. So I have an asymptote at 0. Okay. I've got the other one at pi over 2. So these are going to be skinny. Let me do that again. I can do better. That kind of got a little crooked there. There we go. All right. Now, we've got to graph pi over 8. So what's this halfway between 0 and pi over 2? Okay, that's pi over 4, so we want half of that. So pi over 8 is going to give me negative 2. So right here, I want to go down to negative 2. Then I've got pi over 4, 0. And then I've got 3 pi over 8, which would be the other halfway mark up 2. At least 2. Okay.
Do you want us to do it like, can they be beside each other, or do you want us to do like?
I mean, you can. I think it would probably be easier just to do it side by side. Okay. Like, for example, where would the next asymptote be? It would be at pi. And see, I could just follow the dot patterns. I've got the intercept halfway between, and then halfway on that I go down 2. The other half I go up 2. Okay. And I would say 2 periods is more than enough. Okay. Well, Brandon, do you want to go another one? I can draw another period if you want. More than. I think that's perfect. There you go. Okay. All right. So we've got 3 problems that we did together. Do we want to go ahead and do another one?
Yes.
Which one? 11. Let's take a look at 11. Okay. So 2 cosecant of x plus pi over 4. All right. Now, would someone like to come on up here? Because, it probably gets boring listening to me talk over and over again. Are you sure? Because I've listened to myself sometimes, and I'm like, wow, man, how you doing? No? Okay, I'll go ahead and work another one. All right, so how am I going to graph this one? But you guys completely walk me through it. Completely walk me through it.
So far, we're going to go ahead and change the cosecant because we know it's the cosecant because we see the CST.
Okay.
Change it to, it's like reciprocal.
What's the reciprocal? Sine. Okay, so I'm not going to worry about these. We want to graph 2 sine of x plus pi over 4. Okay.
After that, you want to go ahead and change your color.
Okay, so what would you like me to write out? 0.
X plus 4 pi over 4. And then less than or equal to 2 pi.
Okay.
Times both sides by 4.
Oh, now we won't get rid of it through multiplication.
Okay, I don't know.
We're going to subtract it. Okay, there we go. That's the opposite of the addition. So minus pi over 4, minus pi over 4, minus pi over 4. So those are going to cancel. I have the x that I wanted in the middle. What's the lower? Negative pi over 4, 0 minus pi over 4. And what's the upper? Okay, 1 3/4, so that would be.
So it would be 1 pi and 3/4, right?
Okay, so what would that be as an improper fraction? 1 3/4 pi.
Oh, you want to add an improper? Wouldn't it be like 4 over 8, right?
No, that's pi. That's a 1/2. So let's say 1 3/4 pi. Remember, we multiply the denominator by the whole number and then we add the numerator. So that'd be 7/4 pi. You guys remember that? No? Are we okay with how we got the 1 3/4? Okay. In fact, does anybody want me to show you the subtraction to see that we're going to get 7/4 pi? Sure. Okay. So let's say I have 2 pi, and I want to subtract pi over 4. So I put 2 pi into a fraction because we need a common what? Denominator. What would that common denominator be? 4. So I have to change this to 4. But see here, if I multiply the denominator by 4, I've got to multiply the numerator by the same thing. So this would be 8 pi over 4 minus pi over 4. So we keep that common denominator, 8 pi minus pi, 7 pi over 4. There we go. Okay. All right. So we got that done. Perfect. Now what?
We're just gonna put that to the side and
Okay.
get our original, what's called critical values.
Okay. Which are what?
0 and
Okay. So for sine 0, I heard a maximum.
0 that 2 is not in parentheses.
Okay. Brandon says because the 2 is not in the parentheses, we're going to use it. So how will that change all these?
So change it to just 0 to 0, -2.
Is he correct? Perfect. Okay, so now we know what the y's are. Okay, so you're saying negative pi over 4 will go with 0? Okay. What goes with the other 0? 7 pi over 4. Okay. So we're thinking we could also do this graphically. Here's negative pi over 4, and we're looking for 7 pi over 4, which would be right here. It is 2 pi. Okay, so the distance is 2 pi, and we always divide by what? 4. So what am I going to be adding? Okay, pi over 2. Now here's the thing. We could go ahead and go through with the pattern because, see, right now they have the common denominator. So we don't necessarily have to simplify just yet if you don't want to. It might make it easier. What's a negative pi over 4 plus a 2 pi over 4? That's just 1 pi over 4 plus 2 pi over 4. Ooh. How many pi's would I have? That would be 3 pi over 4 plus 2 pi over 4. 5 pi over 4. And if I add another 2 pi over 4, will it give me 7 pi over 4? There you go. And see, this one was actually really nice to us. You'll notice, is there any that I have to go back and simplify? Nope. Okay. So let's see. At negative pi over 4, and actually, because all we have to do now is just sketch it, would anybody like to come on up and just do that? We already have all the points. Here are my x's, here are the y's. So many hands going up. I just need one. Okay. Oh, ma'am. No, you sure? Think about how much fun it would be to actually look at the smartboard. No? Should throw what? Throw the marker somewhere. Ah! He did not catch it.
That's not.
No. I don't want to throw it too far because someone will be like, what's it? Oh my God. Oh, hit me with that. Oh, yeah, there we go. So nobody wants to come on up. Gotta be somebody. As soon as we do this, we're done.
You know what? Fine.
Rhett! All right. Thanks, sir. All right, let's plot those points. So where would negative pi over 4, 0 be?
One moment. I stood up too quick. Everything's going black.
That's okay.
All right. So 0 and negative pi over 4. Where's that at?
Go ahead, close your eyes.
Hold up. Wait a minute.
Going blank.
Fill my cup. Put some nigga in here. Okay, so here's the origin. So if this is negative pi over 2, okay.
Okay, it's right here. No,
Nope.
That would be in front of the negative pi over 2.
in front of.
Yeah.
Okay.
There you go.
Right there.
That right there is negative pi over 4, 0.
And then
Then the next ordered pair is what?
pi over 4 2.
So it's like, no, so
No, and then this one. Okay, it's right here.
yeah.
You're right about the horizontal, but we want to go up to 2.
Up to 2. My bad. I can't.
Okay. So now we want 3 pi over 4, 0.
So right. Well, here.
That's absolutely right.
Okay, good.
Now we need 5 pi over 4, negative 2. Now look horizontally, how far apart, how many units apart are these dots?
1 pi. No.
Okay.
2.
Pi over 2, right?
Pi over 2.
So we know the next one has to be 2 more units down, and then we go to what?
To here.
What's the next y? Yes, very good. See, that's 5 pi over 4, negative 2. Now the next one, 7 pi over 4, 0. Where would he be?
2 pi over 4.
7 pi over 4.
7 pi. My bad.
Sorry, my 7 kind of looks like a 2.
Over 0. Here.
Yes, that's exactly right.
All right.
Very good.
This was wrong.
Now, we may not even need to necessarily go ahead and draw the sine function. Do we know where my asymptotes would be? Where? Every time it touches the x-axis, we're going to have an asymptote.
Okay, so.
Very good. So that's 1. That's 2. And there's 3. Now, how do we get the graph itself, the branches?
Oh, we go ahead and wherever the maximum.
Okay, we have a branch opening up at every maximum. We have one opening down at every minimum. That's it. That's the graph. Okay. And in fact, we can just go ahead and keep repeating this. If I were to go left, you'll notice how many spaces are there between asymptotes?
It's like in between all the other, it's in between all the numbers.
Yeah. So I'd have another one here. 1, 2, 3, and then one right here on the edge. So this next one here in this region, would it be opening up or down? It'd be opening down. So I want to make it level with the other one. Okay. And then I'd have one right here. There you go. Okay. How we doing? Does this make sense? Okay. All right, good. Well, we will take a look at this on Monday. That's when it's going to be due. Thank you so